Hello and welcome back to Bob's Playground, Part 2, where we're building a Chrome browser extension to test for web page accessibility. We're building using AI, specifically we're using Claude 4 from Anthropic, so it's the latest version of Claude, and we're using the Opus model, which is the more fancy thinking model that they have. It's also the more expensive of the models, so if you're playing along with me, I do recommend you move to Sonnet, which is a lot cheaper. So that said, where we are at the end of part 1, we've built our Chrome extension and we have it working. It's open on screen here. We were testing the bbc.com page using the keyboard accessibility tests that Claude volunteered for us in the last session. So these are tests that Claude invented, not ones that we chose to do. This was Claude running away, doing its own thing. So we don't have a lot in there, but we have something to start from. So the question is, where do we go next? One is to go and actually do this keyboard accessibility testing correctly ourselves. But we also need to sort of build out the architecture of this testing as well to provide more services that we're going to be able to use, whether we're testing for keyboard accessibility or anything else. So what we're going to do in part 2 is to add a local AI as an option to the tool that we have. So the tool we're going to use is Ollama. Ollama provides a server running on your local machine that you can plug different large language models into. So we can use different models for different purposes. For example, we can use Gemma from Google when we want to do image recognition. We can use Llama 3 for when we're trying to inspect the source code of an HTML page. So different models for different purposes, all sitting inside Ollama, which has an API that we can access through our extension in Chrome. So I'm going to ollama.com and I'll choose download. I mean, the reality is I've already got this installed, but I'll go through the process to show you. So let's download that from macOS in my case. But you can see it also has Linux and Windows versions. Let me download from macOS. When we open it, it just says move to applications. You don't get to drag the little icon across. You have to be boring and select move. Now that we have Ollama installed, let's see what models are available to us. So into the models panel there. We have DeepSeek R1, which is the Chinese competitor to ChatGPT and to Gemini. There's Gemma 3 from Google. Gemma 3 is probably the best of the open source models at the moment for doing image recognition. Then we have Qwen 3, Devstral, Llama 4, Qwen 2.5, Llama 3.3, and on down through the list. So lots and lots of models to play with. Depending on what you're wanting to do, you'll choose a different model. You'll choose a different model depending on the logic, on the size of the model that you actually can handle on your PC, and the size of the input context that you need. So there's a whole bunch of things you need to worry about in terms of choosing these models. But I'll just keep scrolling now just so you can see how long this list is getting. But I'm getting into older versions as we go down here now. Then we go back up to the top. In terms of actually installing and running these models, if we go to something like DeepSeek, just to choose one of the models at random. So having opened DeepSeek, you'll see all of the different models that are available to us. There's a naming convention to it where you get the model name to the left, then a colon, then usually a number with a letter B after it. The convention is model name and then variant, and the variant is defined normally by the number of parameters that the model is built with, the large language model is built with. So the smallest we have is 1.5 billion parameters. The largest is 671 billion. 671 billion is the equivalent of ChatGPT, and that requires about 408 gigabytes of memory to run. That's just to load and run. And you need a lot of memory cards, a lot of cores to get anything like any sort of performance out of this model. So people have managed it. There's people who sit with server racks in their garages. We don't have that. I'm just running on a little MacBook Mac Air M2 model with 16 gig of RAM. So I'm a bit limited today in terms of which models I can use to show you. My real work works with much larger desktops that can take bigger models. I still can't take the 671, but I can actually get to the 32 billion models. Today we're going to be down around 8 billion. Even at 8 billion, the response time is going to be very slow, and it might be several seconds between individual tokens. It might be that slow. You might wonder, well, why do you want to do this when we could just use API calls directly to Claude or to ChatGPT or to Gemini? And the answer is cost. Remember, what we're trying to do here is build a platform in which we can easily build automated accessibility testing tools. Now, the problem with accessibility testing tools is if you want to do it across a whole website, and I mean, the plugin we're doing at the moment is for an individual page, but if you're wanting to scrape a whole website and test each individual page with automation, if the AI takes $1 to scrape and test a page, and you have 600 pages on your corporate website, one scrape is going to cost you $600. So there's a cost problem with using AI. If we're just looking at an individual page, maybe $1 here, $1 there, doesn't matter very much. If you're running across 20, 30 pages, you might start to worry about the cost, and say once you're up to 600, you're really going to worry. So by using local AI with the limitations that comes with it, we can usually get enough performance, enough analytics out of that AI that only costs us the cost of running our server. So we're doing it this way because it scales better. So for the little tool that we're building at the moment that's sitting inside of Chrome, we could have just done an API call out directly to Claude. This way we're building for the future. We're building something that we can take out, build into a scraper, build into other tools. Anyway, let's try downloading one of these models. The latest DeepSeek model that came out last week, I think it was, is the new 8B model. So let's choose that. And then we get information about that model, how it compares. And if I scroll down a little bit further, it gives us the performance comparisons. Then it gives us what we really want, which is the instruction how to run it. So to run the R1 model, it's going to be Llama run DeepSeek R1. What we actually want is the more detailed one. We're going to go to the 8B, if I can see it. Somewhere in here, honestly. It is there. There it is. So it gives us the command line to actually run. So I take that and I went out to a shell inside my Mac. We could actually just start and run a Llama. So let's go do that. So I've opened a terminal on my Mac. If you were doing this on Windows, you'll be opening either Command or PowerShell. But here I'm sitting inside my Mac. I'm sitting inside Terminal. Llama is installed, so I can type OLLAMA and then help. And we get the command set. So we have a Llama serve, which is that server I was talking about. We don't need to be running the server yet because we have to build out the tool inside of the Chrome extension. So we're just going to be running directly at the command line. We won't be directly talking to the server. It'll start in the background, we just won't even notice. Then there's another bunch of instructions, including run, stop, pull. Pull is what you use to pull the model down without actually running it for the first time. And then things like copying models, extending, and so on. I'm just going to clear screen, and I'll show you the instruction that we got from the Llama website to run DeepSeek R1 8B, which I've already downloaded, so we don't have to wait 20 minutes for this 5.5 gigabyte model to download, because it is about 5.5 gig. If I select return, and then we get a little busy cursor whilst that model loads. So we've got R1 8B installed and running. So just to see what that output really looks like, let me ask a simple question. What is the capital of Canada? Which is Ottawa. I'm going to say that because DeepSeek's going to take a little while to work that out. So I press return. We get a busy cursor, and then you'll start seeing the thinking that DeepSeek is famous for. And I'll read this out because I don't have I don't have described audio on my little videos that I do, so I'm just going to read stuff myself. But as I'm sitting here talking, you can see how much content you actually get as it thinks. So let's read out the content that is produced. First I'm going to talk about the structure of this content. You'll notice that it uses sort of HTML type tags. You get a think tag whilst it's thinking. It closes the think tag and then it gives you an answer. So the final answer says the capital of Canada is Ottawa, and it double starts Ottawa. So it's giving output that is basically a markup. So it's saying the capital of Canada is Ottawa. It's located in the province of Ontario and was chosen as the capital city in 1857 through a compromise between Montreal and Toronto, which were competing candidates. So let's go back and read what it said in the thinking to get to that point. So it says, okay, the user asked, what is the capital of Canada? First, I need to recall that Ottawa is indeed the capital. But wait, maybe they don't just want a straight answer. Could there be more behind this simple question? And this is one of the issues with DeepSeek. It does go off on tangents a little bit. So it doesn't necessarily take the simple, literal question that you give it. It starts wondering about all sorts of things. And if you think it looks weird on this text I'm about to show you, wait till you see what it does with source code. But let's come back to the content we have here. In the second paragraph, they might be checking for accuracy or verifying their own knowledge. Perhaps they're studying geography and needing confirmation, or someone preparing a trivia quiz or teaching material. Also, possible if they're new to Canada and confused by the name similarity between Ottawa and the state bordering the US. I'm wondering which state they're thinking of. I should confirm that it's not Toronto, which is often mistaken as the capital but isn't. Mentioning the nickname Ottawa for Washington DC helps clarify any confusion from the geography. I never knew that the nickname for Washington DC was Ottawa. Did you? So continuing, including a fun fact about bilingual street names adds context on why it's including a fun fact about bilingual street names adds context on why it's significant, showing cultural and linguistic importance beyond just being the capital. Final paragraph of thinking. Maybe they're looking for more than just name-like historical reasons or the process of choosing Ottawa as capital. But since the question is straightforward, sticking to the concise facts would be best unless a deeper info is requested. Need to make sure the answer is clear but also provides enough context to prevent common misunderstandings. So that's what it was thinking to give that simple answer of the capital of Canada is Ottawa. So if you ever wondered why you get odd answers from large language models, they disappear down rabbit holes in all directions. This is relatively obvious and understandable, and it's unnecessary thinking for a very clear and obvious question. When you start giving it things like a whole web page and start asking it questions about that web page, it starts worrying so much and going down all sorts of rabbit holes, and the thinking grows and grows and grows to the point where it starts truncating itself because it realizes what it's doing. The reality is all we really wanted to see was the capital of Canada is Ottawa. But that's what you get. But it's interesting, you get to see this whole thinking process. The ChatGPT and Claude versions of thinking show you some of the thought, but not all of it. And I think it's because they don't want you to see the rabbit holes their models go down. DeepSeek is a bit more visible. But that's kind of what these tools do. That's it actually running locally here on my Mac. But it's running with a relatively small input context. These DeepSeek models are running with about an 8K input context, which isn't big enough for us. Because what we're going to be doing is testing web pages. We need to give the entire source code of the web page, including all the JavaScript and CSS, to AI to look at. And you're not going to get much in 8K. So we need a much larger input context. So we need to go to a model that allows for that. So we're going to go to the Llama 3 model from Meta, which gives us a maximum of 128K input context. Now the reality is there's 128K of tokens, not characters, remember. And that is simply too large for my PC. So we'll only be able to take a smaller amount of that context down onto this machine. So we'll take maybe about 50K of tokens. Is about all I'll be able to do given the memory that I have and the limitations of this little Mac. So I'll have to shrink it down. I'll change the context down to about 50K, and we'll run that model on here. So I cleared screen, and we have a command to run Llama 3.18b. So we'll just start running it from the command line. In reality, we need to be able to do it by API, but it's baby steps. So let's start just by running it here and see what we get. So it's woken up, it's there. Let's do our usual test. What is the capital of Canada? Let's see what we get from our Llama 3.1. So we get a bit of thinking. And get the capital of Canada is Ottawa. So it's much more brief. You don't get the thinking. It doesn't have that thought process that you're seeing on DeepSeek, or that you see on the newer models in ChatGPT or Claude. So we're looking at something a bit more old-fashioned in terms of AI, but weirdly it is. But it's good enough for what we want to do. What I do need to do is to try and control the context that we're working in, because the default context here is going to be a bit on the small side. So there's a command I need to type for that, which is the set parameter, where we set the size of the context for the application. So in this case, we're actually set it at 50,000 rather than 40,000. So we have plenty of context for pasting in entire web pages. So I press return, and we've set our parameter. This can be set up and built directly into the model, but for now I'll just do it at the command line. So we're set up to do stuff. Let's go find some source code and ask questions about source code. And let me introduce you to my test environment. I have a 4-page website that's full of accessibility issues that we can use to test. So if you want to go looking for it yourself, it's publicly available. It's bobd69.sg-host.com. So it's that thing there. So you can see there's carousels, there's forms, there's cookie notices, there's everything you can imagine on this site. All we want to do for now is to take all of the code over and give it to Llama and see what it can make of it. So I'm going to inspect the page. I'm going to go up to the top. I'm going to go to HTML, and I'm going to make a change actually before we do take it over there. I'm going to change the language at the top here to FR. So we're going to have the wrong language code for this content. And then I'm going to come down, I'm going to copy the element which gets all of the content on this page, and we're going to paste it into the prompt. So let's think of an accessibility question we could ask to go with that source code that's relatively simple. So I think what we're going to ask is, what is the dominant text language of the following HTML web page? And then I'm simply going to paste the code in. So it's not too long a piece of code. If I scroll back up through here, it all should be inside the history. So from the HTML at the top with a lang of FR, which is we've got wrong for a page that's full of English, but there is some French and German in there in the language switcher as well. So that's the question we're going to ask. Just press return to start the prompt. Ignore the output that we're getting there, let's just look at the result that we get. So now the prompt is spinning, and this may take a little while to return. And it did take a very long time to return. About 6 to 7 seconds between tokens in this output. So ignore the time at the top of the screen. I stopped doing this to go and do some other paid work, and I've come back over to it now. So the time code doesn't mean anything, but it genuinely did take a long time, so 6 or 7 seconds per token on the output. But let's go through and see what it actually said. So the answer that it came back with was that the dominant language of this HTML web page is English. This can be determined by several factors. Then it gives 3 bullet points. 1. The lang attribute in the HTML tag is set to FR, which suggests that the page is intended for a French-speaking audience. However, upon examining the content of the page, it has become clear that most of the text is written in English. 2. The majority of links and text on the page are in English, with no signs of French language used other than some titles and possibly some URLs. 3. The HTML structure, including the use of elements like header, nav, and footer, follows standard web development practices that are common in English language websites. That one I'm not sure about. I think if it's worrying about header, nav, and footer, typically HTML stays like that whichever language you're developing in. So on to the final paragraph. It says, overall, while the lang attribute suggests a French audience, the content and design of the page indicate that it is primarily intended for an English-speaking audience. Therefore, I conclude that the dominant language of this HTML page is English. And that conclusion is really important. If you think about what we get out of current automated testing from commercial testers, they don't pick this up at all. They would have looked at the HTML tag, seen that we actually had one, that the code was correct, that it was an FR, so syntactically it was correct, a language was declared. They would never have got that it was the wrong language on the page. So we're catching something that the automation doesn't. Let me show you that. So coming back to our page again, I'm going to go to the Axe Dev Tools and scan the page. And let's scroll down through the issues that we found. ARIA hidden elements must not be focusable. Minimum color contrast. Documents must have a title element. Interactive controls should not be nested. Heading levels should only increase by 1. Documents should only have 1 landmark. All page content should be contained by landmarks. And elements should not have a tab index greater than 0. Nothing about the wrong language on the page. And I could have pulled up any tool. This doesn't have a go at Axe. It's simply the tools that we've had until now haven't really gone after that. They haven't gone after the language on the page at all. They've looked at the syntax. It's not just Axe, it's Arc, it's Wave, it's Site Improve. All of those tools have never really sat down and looked at the text on the page and compared it with the corpus of English, French, German, Spanish, and so on to identify the language of the page. And we're able to do it quickly and easily because we have AI that can already identify that text on the page. The thing is, we can actually go further as well. We can do another test. We can look for foreign words on a page that's basically English. And we can ask AI whether those foreign words or phrases are inside language tags. So we're looking for a lang attribute in a span, usually around those foreign words on the page, so that a screen reader would know how to pronounce those foreign words. And we can get Llama to do that for us. Let me show you. So let's ask a supplemental question. Are there any words or phrases not in the language on the page, and are those words and phrases wrapped in a lang attribute to identify the language. So let's ask that question next. And we get the spinner again, and now it's starting to think about the question. And the final response, and it did take a little while for it to write out, again about 7 to 8 seconds per token. The answer was yes. Upon closer inspection, I noticed that there are several words and phrases written in French, the non-dominant language, scattered throughout the page. Examples include, and then what's supposed to be Espanol but it doesn't have the right font, Spanish, Francais, or what is basically supposed to be Francais, says French, and then conditions, sorry, my French is terrible, condition générale, French for general conditions. And then it found a Unicode character that is commonly used in French. So it's given 4 examples there on the page. They're mostly from the language switcher on the page. That's where it's found them. So it says, however, I notice that some of those words and phrases are not wrapped in a lang attribute to identify the language. In fact, none of the non-English text on the page has a lang attribute. This suggests that the author of the page may have intended to provide multilingual support, but did not properly implement it using HTML attributes like lang. So yes, it did notice whether there was lang attributes on foreign words on the page. That gives us another success criteria inside of WCAG that is not normally covered. It's 3.1.2 language of parts, and it's something we normally catch only on manual inspection. And even on manual inspection, they can be hard to find. The ones that were being picked up here by AI is from the language switch, and you can see English, you can see Espanol. You don't see the French, because there's another bug deliberately built into this page that's hiding some of the foreign words as well. So we were looking for these and testing for 3.1.2 manually. We'd be looking for foreign words on the page, then going to inspect. Well, yes, there's Espanol. Roll presentation, then Espanol attribute associated with it. So there should be lang equals es. So yeah, it's catching things. It's catching issues that we would normally get only by manually inspecting, by literally scrolling through the page, looking at all of the text we can find, looking for anything that's not in the dominant language of the page, and then inspecting the HTML, looking for those language attributes. So to recap what we've been able to do, we've been able to identify the language of the page, identify that that language of the page is incorrect. We've been able to identify other words on the page that are not part of the dominant language, and identify whether they have lang attributes attached to them or not. That allows us to fully cover 3.1.1 language of page and 3.1.2 language of parts, and to do so automatically. The additional success criteria beyond that, if the language of the dominant language of the page doesn't match the language at the top of the page, we're actually failing 4.1.2 name role value. So we're actually catching another 4.1.2 as well as 3.1.1 and 3.1.2. And none of those, bar the basic semantics of the language definition, get picked up by existing automation. So by building what we're going to build we'll create a tool that doesn't yet exist on the commercial space. I'm sure it's going to arrive very soon because everyone's playing with AI, but at the moment, compared to the plugins that we have for Chrome, for Arc, Axe, Wave, we're not going to see it. So we have something new and special that we can use ourselves, and that's why I really want to encourage people to go build their own test tools, to take ideas, to take things like 311, 312 and see what we can do to improve on the existing state of testing, to test those parts of the success criteria that have until now not been tested. So let's review where we are in developing this extension. At the end of part 1 we had a working tool that would sit inside of the dev tools inside Chrome that would run some basic accessibility tests on keyboard accessibility. We've moved on from there to start considering how to expand upon that and provide local AI that we can use to help us do this testing. To that end, we've experimented with Ollama, which is a platform that allows us to bring in multiple large language models to use in different contexts. We've installed that and run that directly on a little laptop on a MacBook M2 with 16 gig of memory, and we've tried two different models. We've tried a version of DeepSeek and a version of Llama 3, and we use Llama 3 to inspect some source code from a test page, this test page, just scrolling back up to the top, that we passed in the entire source code together, the HTML, the CSS and the JavaScript for Llama 3 to inspect, and we asked questions about the language of the page. We asked what the dominant language of the page was, and we asked what non-dominant words were on the page and whether they had lang attributes associated with them. And we got a response from AI. We got that response for looking at non-dominant language, it's a little bit we've just done. So we do have a tool that we know that will make this work. We're going to have to change the format of the queries. We're going to have to access the language model through API from, says if I can go back to it, from our DevTools environment. So we have to do API calls out to run this, to pull the answers back. Those answers are going to have to come in a more structured form than the free text that we've allowed Llama 3 to use so far. So we're going to have to get it to come back with content that's probably in JSON that we can then use to build the results inside the tool here. And that's what we'll do in part 3, is we'll use the API to access the Llama 3 environment inside of Ollama. So that's what we'll do in part 3. But part 2 we're not doing bad. We've already got a working environment. We've now got a way to deal with local AI that's essentially free, that we're not paying for every time we want to do an inspection, every time we want to do a query, and we've found a model that allows us sufficient input context that we can throw an entire web page into AI and get answers. So I'll see you in part 3.